So you're not actually going to take this homework quiz, but as you look at this, what is the difference between linear and nonlinear relationships? Provide at least 3 differences between the two types. So this is more to prepare you for your tests. If you think about tables, graphs, and equations. So as I'm looking at this, I might be thinking linear graphs are straight lines, nonlinear are going to be curves. As I look at linear tables, they have repeated addition or subtraction, and nonlinear might have multiplication, they might have division, or something else that I don't recognize, different changes up and down. Linear equations are always going to be in our form y equals mx plus b, while nonlinear equations are going to show division, maybe of a variable or multiplication. So when you think about those nonlinears, you might have something like y equals x squared. You might have something like y equals 2 to the x, where you have different exponents. They might show division, y equals 2 divided by x. All of those are going to be nonlinear equations. So to be ready for the test next week. Analyzing data, if you turn in your workbook. Now, as you watch this video, you will want to pause and take notes at different times and pause it. So we are creating graphs to describe relationship between two variables. We're going to look at patterns, looking at that cluster, what is an outlier, positive and negative correlation that we've talked about, linear, nonlinear. And as we look at these problems, we're going to kind of decide, should it be a straight trend line or should it be a curve, which is nonlinear? And we're going to make some predictions. So how do you find 4% of a number? Well, first off, if we're going to write 4% as a decimal, you move the decimal over 2 points, it is 0.04. If I'm asked to find 4% of 20, what am I going to do? I'm going to change it to 0.04, and I'm going to take that times 20. So as I'm multiplying that, if I think of taking 4 times 2, I get 8. This is going to be 0.08 as I'm looking at that. So that's just kind of a hint as what we are looking at. As you look in your notes, looking at problem 1, as we are taking a look at investing. So it says, one day, on the day Chantel was born, her Uncle Charlie used $100 to open a savings account. He planned to use the money in the account to buy Chantel a gift for her 10th birthday. Charlie forgot about the money until the last week he received an invitation to her 14th birthday. Charlie called Chantel and told her about the account. He said, "I'm sorry I forgot about your 10th birthday. Would you like me to give you the money in the account now, or would you like me to leave it there for your 18th birthday?" So if you're thinking about that, do you think 14th or 18th birthday? We're going to take a look at some data, and when we get to this next page, this is definitely where you're going to want your calculator, and you're going to want to pause it so that you can help fill in this table. So Charlie's account was earning 8%, which is pretty good percentage right now, at the end of each year since Chantel was born. Charlie had not deposited or withdrawn any money since he opened the account. How much money would she have on her 14th? So here is how we're going to complete the table that is on the bottom of this page, right as you take a look and you're earning interest. So first thing, 100 times 8%, 0.08 gives us $8. 8% starts the amount of the interest we earned at the end of the first year. So the first year we put in 100, end of the first year, we now have 108. We add that on. Now we're going to take the 108 with the interest we earned and take it times 8%. That gives us 8.64. Now we're going to add that on, 8% of 116. So at the end of that year. So as you look at this table, we are going to be filling this in. So we are right at this point, 116 times $116.64. How did we find this amount? We took 116.64 and we took it times 0.08. So we're always taking the amount that's over here times 0.08, the 8%, to find this 9.33. Now we are going to add these two together. So if we think about that, we are now adding these two to equal 125.97. How do I find this next amount? I'm going to take 125.97 and I'm going to take it times 0.08. So I'm going to have you do that on your calculator. And I want you to try and pause this and add a few of these in and really go up to about 6. And then you can unpause it and see the table that I have. So if we would continue this pattern, this is what we are looking at. This is always 8% of the amount, and then we added it on. So on the 14th birthday, we're up to $293. Pretty good for 100. But notice this column is continuing to go up. So if we're going to find this next one, if we're going up to our 18th birthday, we might want to try and make a decision. On the top of the next page of your notes, we are going to make a graph. As we make a graph from the data, we want to think, is this going to be a straight line or a curve to model our trend? As we take a look at this, I want you to put the account balance on this side for your y-axis and the birthday number. So we're going to go birthday 1, 2, 3, 4. We're going to go up to 14. And then we're going to plot the points. So if we are taking a look at those, we know that at 0, it was 100. And it goes up slowly. So when we set our scale, I'm going to have you set this scale as you take a look at it. So we are going to go up by our 14 birthdays, 25, 50, 75 as we continue to go up. And then you're going to plot the points. Again, you probably want to pause the video. I'm going to show you what it looks like. And these are your points as we graph that. So it's definitely a curve. As we answer the questions, is the graph linear or nonlinear? If we were going to explain that, we would definitely say nonlinear. And then you want to give the reasons. The pattern is repeatedly multiplied by 8%. It's a curve graph. The table does not increase by a constant rate. So when you look at the test this next week that we're going to take, you're going to be asked to give reasons for something being linear or nonlinear. 2 or 3 reasons is an awesome amount of reasons instead of just it is not a curve or it is a curve. As we finish taking our notes for today, we're going to analyze this data. It says about how much money would be in our account on our 18th birthday. Explain how you found that. So again, we want to go back to what she had on her 14th birthday. As you look at what she had on her 14th birthday, on her 14th birthday, she was up to $293.70. We're going to take that times 0.08, and then we are going to add that on. As we take a look at that, on her 18th birthday, she'll have about $400. And again, this is not totally exact, but about that. How could you determine it? You'd continue the table or the graph to find your answer. So it says, do you think Chantel should take the money in her account now or wait until her 18th birthday and explain your answer? And again, this would not matter. Maybe you need the money now at 14 that you don't need at 18, but it would be quite a bit more. So probably to keep it in because it is going to increase quite a bit in 4 years. Again, if you need to pause the video, make sure you do so. We are going to continue with the notes on Unit I11, so you'll fill those in also today. I mentioned we were going to continue with the I12 notes. Here's a problem again for the end of the year review. Again, if you want to pause this. First thing I would find is the y-intercept. It's our nice point that we are starting with at 150. If I'm looking at the slope from the 2 points, the biggest mistake that a lot of you made when we were doing the I7 and some of the other ones is you didn't look at the scale. So from 150 to 50, we are going down 100 and over from 0 over to 5 divided by 5. So as I'm taking a look at my slope in this case is going to be negative 20. I'm going to write my equation, y equals negative 20x plus 150. Also thinking about what those things mean. So you're going to finish tonight the I11 and I12. We are actually not going to do this experiment, but here's what is happening. So as you fill the beaker with water, a few drops of food coloring, we're going to pour half out each time and then return it. So continuing to pour half out. It says now that we have our data, let's look at the water in the beaker and that you have after you start pouring. So if we start with a large glass And if we are looking at that and we fill it up and we are going to always dump out half, the pattern would be that the amounts are always going to be divided by 2. So if we start with, if we are thinking about, as we look at this, 32 ounces, the next time it would be 16 ounces. Then we'd go to 8 ounces. So each time it's going to keep going down by half. So it says they are not going to be going down by equal amounts, so it is not linear. It's going to be a curve. In your notes right now, that if we did this experiment with 32-ounce glass instead of the size we used earlier, what data would the pattern look like? So we would start at 32, the next one would be 16, and as we continue that pattern, if you take a look at that, we should have, as we are taking a look at that, is it going to let me move it? So as I continue that, we're going to have 8 and then 4, and we're going to continue with that pattern, 2 and then 1. And as we look at that, it's keep getting smaller, a half and then 0.5. So if we are going to do that, we are going to say, again, that we are dividing by 2. And again, if you need to pause the video to fill in your table, make sure you do so. On the top of the next page, we are going to make a graph of our data. So again, as we take a look at that data, we want to put some labels on our graph. So if you are putting your labels, we're going to put the glass numbers, which are going to go from 0 to 10, and we're going to have the amount of water. But this time, some of the mistakes that some of you have made is you don't set this as a constant. You want to use 32 and 8 and 16, 8, and just the numbers in your table. You cannot do that. So when you take a look at this, we are going to be taking a look at making sure that this scale, and again, if you have to pause it, you are now going to plot those points. So 132, we're going to plot 216, 3, 8. So on that table, you're going to plot the points. As you plot those points, you should see something like this. At 1, it was 32, 2 was 16, 3 was 8, and it gets closer and closer and closer. Now you can definitely see that it is non-linear as you look at this. We want to answer the questions on that bottom of that page before you work on your homework, and you are going to want to make sure, if you need to, pause this so that you get everything down. So describe the pattern you see on the graph. If we are looking at that pattern, we'd say it's non-linear. It's a decreasing pattern. If you continue to add glasses of water from the last glass into the new glass, how much would be in glass 20? So remember, we stopped at glass 8. So we're going to keep going by a half. Oh my gosh, that is getting small. We want to think of that on the 20th glass. If you kept dividing by 2.0, like, can we even measure that is what you want to think. So if you continued to add glasses and pour half the water out, now we assume that it's going to get closer and closer. Will you ever run out of water? And in life, real life situation, technically you're going to run out of water because how do you show that much? However, eventually a small water, it becomes difficult to pour half of it out. So eventually we would. As you are looking at that, you're going to be doing your homework. As you do your homework, I was just looking back at the I11 and 12 as you are working on your homework. It is going to be really important that you set those scale. So even as you're taking a look at graph 2 on I11, to when you do question 2 is to set that graph and look at that. When you're doing on page for I12, making the graph, again, just think about those variables that you are looking at. Thanks.